Welcome to U sub. U substitution is probably the most commonly used integration technique that we have. Before I can jump into an example, I need to talk about the differential form of the derivative. And the only difference is instead of writing our derivatives like this, we're going to move the dx to the other side and write them like this. So for example, if u is root x, then if we just take the derivative du dx, we get 1 over 2 root x. And when we write this in differential form, we're just going to move the dx to the other side. So we're going to write du is 1 over 2 root x, and then we're going to put the dx here. All right, I think the easiest way to learn U sub is just to do a bunch of examples. And so I'm going to do some here, and then you have a lot in your homework. So consider this example here, and we want to find an antiderivative for this. Well, we could multiply it all out, but that would take a while. So instead, let's make a substitution. We're going to change variables. I'm going to let u be the inside function, which is x squared plus 1. And then du, the differential form of the derivative, is 2x. I just take the derivative, and then I put the dx on this side. Okay, bummer. I don't have 2x dx. I have x dx in my integral. So no worries. You can modify du by a constant. So I'm going to multiply both sides by a half. 1/2 du is x dx. Now, one thing I'm really particular about is when you modify du, I want you to write that on a separate line. So don't write down what I'm about to write down. So if we had du, because I'm going to erase it, is 2x dx, I don't want to see this. Over 2 crossed out 1/2. Because when you do that, you tend to make mistakes when you put that back in your final integral. So please don't do that. Just write a separate line like I did here. Okay, now we're ready to make our substitution. This original integral is, I'm going to take 1/2 and bring it out front, integral du. That takes care of the x and the dx. What's left is u cubed. All right, so everything in that integral is accounted for in my new integral. And so now I can integrate. And so when you do the substitution, hopefully you'll end up with an easier integral, because that's the point. So this is 1/8 u to the 4th plus c. And then we want to leave our answer in terms of x, because that's how it was given to us. So we back substitute 1/8, and then u was x squared plus 1, and that's to the 4th plus c. And there's our antiderivative. Now I encourage you at home to take the derivative of this function. You're going to have to use the chain rule and see that you actually do get the integrand from our original integral. All right, so now I want to formalize this process and give you a set of steps you can follow in order to do a u substitution. So as I go through the steps, I'm going to do this example up here. And the first step is to choose u. So this is the art of u substitution. I'm going to let u be the inside function, 1 minus 3x squared. And then I'm going to compute du. So just take the derivative of 1 minus 3x squared, which is negative 6x, and then put the dx on this side. Okay, I don't have in my original integral a negative 6x dx. I have an x dx. And I rewrote that integral like this just so you could see my x dx sitting right there. That's sort of a mental step that you would do. So in order to get an x dx, I take du and I divide both sides by negative 6. So negative 1/6 du is x dx. And again, I want to see that third line when you modify du. All right, great. Now we're ready to rewrite our integral. So our original integral, I'll call it I, give it a name. You don't have to do that. I is equal to, I put constants out front, negative 1/6 integral du, and then I see what's left. I've taken care of the x dx, so what's left is a 1 over u squared. So I'm going to write that as u to the negative 2. All u's. Never, ever, ever have u's and x's in the same integral. There's some yahoos out there on YouTube that have videos where you're doing that, and it's just wrong. So don't be a yahoo. Okay, so now we evaluate the integral. And that's what, I have an exclamation point there, because sometimes people forget to do that because they're so excited about the u substitution. So when I evaluate, I get positive 1/6 u to the negative 1 plus c. And then when you have an indefinite integral, you want to go back to x's. So 1/6, and you back substitute, u is 1 minus 3x squared to the negative 1 plus c. And there we go. There's our answer. All right. Can you do u substitution with a definite integral? Yes, you can. And here's how. I'm going to go through with this example. So I'm going to choose u to be, again, the inside function, u equals cos x. And I say inside because I could rewrite this integral as cosine of x quantity squared sine x dx. So I'm going to let u be cosine x. That is the inside. And I'm going to take du, which is negative sine x dx. And it's negative because cosine starts with a c. Now I have positive sine x dx. So I'm going to divide both sides by -1. Negative du is sine x dx. All right, next step, rewrite as a u integral and change the limits. So my integral will be, I'm going to put the negative out front and a du, and then I look to see what's left, and I see that a u squared is left. To get my new limits, I evaluate u at the old limits. So you can make a box for your new limits, but you don't have to do that. My old limits are 0 and pi over 3. And to get my new limits, I evaluate cosine x, that's u, at the old limits. So cosine of 0 is 1. That's my new lower limit. And cosine of pi over 3 is a half. That's my new upper limit. So a 1 goes here, and a 1/2 goes there. Now, if it bothers you that the lower limit is actually larger than the upper limit, you could rewrite and switch the limits, 1/2 at the bottom and 1 at the top. But when you do that, you introduce a minus sign. But that's great because that will cancel this minus sign. So we'll have positive integral from 1/2 to 1 of u squared du. Now, you don't have to do that step. If you want to evaluate this integral, you can, and you'll get the same answer. But I'm going to evaluate this integral, and that's the third step. So this is equal to 1/3 u cubed between 1/2 and 1. I'm not going to go back to x's. I'm never going to see a cosine or a sine again. This is the beauty of changing the limits. And so that's 1/3, 1 cubed, minus 1/2 cubed, which is an 8. And so that would be 1/3 times 7 over 8, which is 7 over 24. Perfect. And I just want to end with a caution not to use u sub when you don't need to. Sometimes the book or the homework will encourage you to do a u sub for things that are just Bible formulas. For example, we know that the integral of e to the 2x dx is 1/2 e to the 2x plus c. But if you really wanted to waste time, you could find that same answer by doing a u sub on this. U is 2x, du is 2 dx, divide both sides by 2, ... And you get the same thing. So you get the Bible formula if you do a u substitution here with u equal 4x and here with u equal 3x. So just don't do it. Don't waste your time. Okay, and that's the end of this section.